This is our first video for Chapter R review. We're starting with section R.5, Factoring Polynomials. Factoring is a very important skill that we will need for most of the course, and that's why we're going to the review section, even though these are topics we really should already know, to refresh. Okay, so we're going to start with the difference of two squares. If we multiply x minus a times x plus a, we get a difference of two squares, x squared and a squared, difference being subtraction. So factoring is just doing that in reverse. So if we have a squared minus b squared, that factors to a minus b, a plus b. Now, of course, the order of these two factors doesn't matter. 2 times 3 is the same as 3 times 2, so you can put your a plus b first if you like. The first example, factor the difference of two squares, start us right off the bat with a difference of two non-squares. 3 is not a perfect square, and neither is 27. So, what we have to consider is there a common factor in these two terms that we could pull out and leave behind a difference of squares that we can then factor? Use your calculator if you're not sure. 3 has the only factors of 3 and 1, so we go to 27. Does 3 divide evenly into 27? It does. Great. So we can pull out a 3. And what's left? X squared minus 9, right? Okay. 3 times x squared is x squared. 3 times negative 9, negative 27. Now, I'm going to add in, so what we have here now is a difference of two perfect squares, right? X is a perfect square because it's x squared, and 9 is 3 squared. But I want to make sure I identify that. So I'm going to put in this extra step that you probably won't need on every problem, but it might help you on some. So let me do that. I'm going to keep my 3, can't lose that, because I'm saying that this is equal to this is equal to this, and if I throw the 3 away, it's not equal. And I'm going to use brackets so I can identify what's being squared in the first term minus what's being squared in the second term, because I don't need a squared and b squared. I need a and b to be able to factor this. Okay, so that's the step that you may not always need, but I have seen people write x minus 9, x plus 9 for this problem, right? So this is how I'm making sure I don't do that. Keeping my 3, now I know that that's a squared, that's b squared, so it's a minus b, a plus b, right? X minus 3, x plus 3. Or I could write those in the opposite order. Okay, that's problem A. Let's look at B. Now, this case, it's a difference of 2. Are they perfect squares? Well, let's use that brackets trick to see. I'm going to see by saying, here's my bracket, what is being squared in the first term and what is being squared in the second term. Okay, 4. To get a 4, I would square 2. To get an x squared, I would square an x, right? To get a 25, I would square 5. To get a y to the 4th, what would I square? A y squared, right? So see, this one's kind of tricky. It's a good thing I've identified my a and my b, because now I simply go straight to a minus b, a plus b, right? I can set that up, minus and plus, or plus and minus, whatever you like. What is a? It's 2x. It's 2x. What is b? It's 5y squared. It's 5y squared. Now, I didn't point out at the beginning, which I should have, that these two terms have nothing in common. So I couldn't have even pulled out a greatest common factor, a GCF here. 4 and 25 don't share any common factors, and neither do x and y. So we're done. We've completely factored. All right, that's the difference of two squares. Now let's look at the sum and difference of two cubes. They start by showing you how you can multiply to get, now this is sum and difference. Notice we didn't have a sum of squares. The sum of two squares, it does not factor, okay? But the sum of two cubes and the difference of two cubes both will factor. And their patterns are very, very similar. So if you learn one, the other one is very simple. Okay, so now we've kind of got a key here as to what we want to do, although we're using a and b instead of x and a. The sum of two cubes factors. Notice it's a binomial and a trinomial. So a binomial, I'm going to make room for that, and a trinomial. Okay, I know I've got to set that up. So just kind of visualizing patterns really helps. And it says it's a cubed plus b cubed. So my binomial is just going to be a plus b. Then what happens? Then my a, here it was x, gets squared. Okay, so now it's an a squared. Then it's the two together. Here it was a and x, a and b. So a and b multiplied together. And finally, plus b squared. Okay, so it's a cubed plus b cubed. So I need ab, just like I had ab. And I need a plus, just like I had a plus. So I'm just literally taking the cubes off. The trinomial has squares on either end and the two together in the middle. Let's look at the difference of two cubes and notice how similar they are. We have a binomial and a trinomial, identical, only difference are signs. That's it. So if you learn the pattern and you learn the signs, you've got it. And there's a clever way to remember the signs. This was plus. This sign is the same as that sign. So I put an S above it. This sign is minus. That's the opposite of what I started with. And notice for both of these, the last sign is always positive. So if I remember soap for my signs and I got my binomial, my trinomial, then I've got it. So notice the sign is the same in the second one on the difference of cubes. It's the opposite, and it's always positive. Okay, so those are our patterns. You just have to know these. This is something you just need to know. Okay, practice, practice, practice. Factor the sum or difference of two cubes. All right, do we have two perfect cubes? Well, here's a handy thing to do before you get started is you get your calculator out and say, what are the perfect cubes? Well, 1 cubed is 1, and that's not going to help us. But 2 cubed is 8. 3 cubed, calculator tells me is 27. 4 cubed, calculator says 64. 5 cubed, 125. I'll stop there, and if I need others, I'll come back. So now I have a list, and I'm good to go when I start looking at my factors here and my terms. All right, 27 is on the list. 125 is on the list. X cubed, perfect cube. I know I have two perfect a sum of perfect cubes. I'm going to take that step that I said is a little bit extra and make sure I don't mess this up. What is being cubed here and what is being cubed here? Well, 27, that's 3 cubed and x. And here for 125, I need a 5. So now I've got my a and my b, and I'm going to do my binomial and my trinomial. I'm going to do my 3. Here's my a, here's my b. I need an a squared. I need over here a b squared. And in the middle, I need a times b. I know it's getting a little small, but 3x times 5, right? There's my a times b. And now I need my SOAP. This was plus, so same, opposite, always positive. And now you just come back through and simplify. 3x plus 5. 3x squared. 3 squared is 9. X squared is x squared. Minus 3 times 5 is 15. And then we have an x plus 5 squared is 25. There we go. Following the patterns. Okay, let's look at the next one. 27 is on our list. 64 is on our list. X cubed is a perfect cube. And y to the 6th is a perfect cube. So here we go. Let's break it up into our a and b, just so we don't make a mistake. 3x cubed, that's how you get 27x cubed. And then this one's minus, what do we get for 64? That's 4 cubed. What do you suppose we have to cube to get y to the 6th? Y to the 2nd, right? Y squared times y squared times y squared. It's going to give us y to the 6th. Okay, so now we do our binomial. I'm going to use brackets this time for the tries till I simplify it. For the trinomial. Okay, a and b is 4y squared. Hang on just a sec. Forgot my 4. 4y squared. Then I'm going to have a 3x squared. I need my 3x times 4y squared in the middle, and I need 4y squared squared on the end. There's my A times B. Now it's SOAP. Same, which is minus, opposite, which is plus, always positive. And then the last step is just to simplify. So what's here? This is 9x squared. This is plus 12x y squared plus 4 squared is 16. Y squared squared is y to the 4th. And let me add one last thing to you. You may be thinking, I'm supposed to be factoring. How do I know this is completely factored? I mean, I can see the binomial is, but how do I know that trinomial is completely factored, or this trinomial is completely factored? Well, it will be prime every time, so it is completely factored. This will not factor down to any further, neither one of these. There are no common factors to pull out, and you can't do any other factoring techniques. So you know that they're prime. Okay, we'll continue this in the next video.